हरिः कर्ता।
Let's apply universal functions on ND array. So NumPy provides familiar mathematical functions such as sine, cos, and exponential, exp. Uh, so in NumPy, these are all called universal functions because these sine, cos, and these are called mathematics. This comes under the mathematics, but these functions help us in dealing with lot of physics, and mathematical problems together. So that's why NumPy is a scientific tool for for a statistician or mathematician to use it using Python. So with NumPy, these functions operate element wise on an array. So producing an array is as output. The output what we get as is an array. So universal functions. So let me take a new array. So np dot a range. I'll just directly put 3 without shape. So we'll get the print, we'll do the print p, we'll display it, and it consists of 0, 1, 2. So I'm gonna do exponentiation directly. So np, so I want a new array which consists of the exponentiation. So e power 0, e power 1, e power 2, these values I want. So np dot exp, directly I'm using universal function exp, and inside that I will mention b, and here is that. So 1.0, 2.71, 7.38. It's basically e power 0, e power 1, e power 2. Clear? So similarly we can do, so np dot sine of b, and here you got 0, sine 0 is 0, absolutely correct, and sine 1 is 0.84, and sine 2 is 0.90. So let me create a one more thing. Okay, let me do this first. Let's play. Let's have some fun here because we have our mathematics with us. It's better to have some fun. So np dot cos. I'll go with the cos. So cos, yeah, cos, and then I'll see cos b. Oh, that's okay. Yeah, you got it. 1.0. Obviously, cos 0 is 1. Absolutely correct. These things we used to by heart in 10th class and 12th standard. Cos 0, sine 0, cos 1. So sine 0 is 0 and cos 0 is 1. Correct? Then we have cos 1, that's 0.54, and cos 2 is minus 0.41. So I am going to do hyperbolic. I want to see the hyperbolic and see what's going to happen. So sine h, so whether we have this sine c, we have single sine h, and I'll give b and c. Okay, it's the value changes for sine hyperbolic because sine h is e power x minus e power minus x divided by 2. So that's the reason the value changes. This sine hx, cos hx, and tan hx, these hyperbolic functions, we use it as a activate functions. We use it as a activate functions in deep learning, or neural networks. If anybody, any data scientist is watching, he would have known about this. So let me take angles an. Okay, so this time I will specify what I'm gonna do is I will give np dot since directly I'll give a list Okay, np.array, and inside that I'm gonna give sequence of sequences. So what I will do is I will mention 0 and 30, 45 and 90, 120, 150 and 180. And the next one, let's continue the second list. So 230, sorry, 210, 250 I will give. Sorry, I'll give 240 and then 270, 240 and 270, 300, and I'm gonna give 330 and 360. So let me reduce one here. So either 30 and after that instead of, okay, I'll give 45 and I'll add one more, the important one, 60. The 90 will keep 120, 150, 180. Okay, this is one and this is one. Obviously these are not same, so what I'm gonna do is I'll create two matrix. Okay, two arrays. Yeah, it's fine now. Execute. So let me say angle 1. Yeah, similarly angle 2. I'll give np.array and I'll add this simply. Let me remove this and execute this also. let's let's add universal functions now. So angle 1, so I want to see sine. Oh sorry, that's my mistake. So angles, so values, so ang 1 and np dot ang 1. So I want to use a sine 1, so I'll say ang1. Remove this and here. So now let me print the values for you. So print values, and here is that. So sine 0 is 0, sine 30 and sine 45 and point. I don't think it has considered this as an angle, so it hasn't considered this as an angle, so we got some other values. So even so sine 90, we got, okay, 0.489, sorry, it's a 0.89, it's close to 1, that's okay. And similarly we can do it for other one. So values 2, np dot cos and ang 2, and here let me print the values. No, values 2, and here are the values. And okay, this is a 270 and 360 is this. That's okay, that's taking us a radians. Okay, fine. So that's how we use universal functions. And there are a few more things. I also request you to look into any apply along axis method, argmax method, argmin method, argsort method, average, bin count method, seal, clip, conch, correlation coefficient method, COV, cross, comprod, cumulative sum, diff, dot product, floor, inner, invert, lex sort, max, maximum, mean, median, min, minimum, non-zero, outer, prod, re, round, sort, and many more. I would request you to see all those things and explore.